All right. We should be transitioning over to my desktop here shortly. Ed, can you confirm that you're seeing my desktop all right?
We're good to go, sir. Go ahead.
All right. Well, thank you very much. As Ed mentioned, my name is Eric Weisbrot. I'm one of the applications engineers here at Infinity QS, and today we're going to be talking about getting the most out of defects data entry and analysis. And also, as Ed had mentioned, this is kind of the first of a two-part webinar on attribute data in general. Today we're going to talk about defects data, and in 2 weeks we're going to circle back around and talk about defectives data. And the whole topic and arena of attribute data is actually pretty large, and so these sessions we're going to try to keep as an overview. We'll start out with some PowerPoint slides to kind of talk through some concepts, and then go into the software and show some examples of the things that we've talked about, and give you some ideas for things that that may work for you in your environment. And since this is one of our public webinars, if you haven't attended before, if you have any questions as we're going through, please use the Q&A tab to type your questions, and we'll address those at the end of the session. So, all right, without further ado, before we start just delving right into defects, as I mentioned, we're talking about attribute data in general, and this week we're going to talk about defects, and in 2 weeks we'll talk about defectives. Certainly we need to kind of compare and contrast defects versus defectives so that we can understand which is appropriate for us to use and in what kind of circumstances we may need them. So a great question would be, well, what's the difference between defects and defectives? And many customers have our SPC pocket card from which I lifted these following definitions/quotes. So defects data are count data and are described with a Poisson distribution. Counting the number of visual blemishes on a part or the number of support calls received in an hour are examples of defects data. Okay, so we're counting, multiple instances of things. Contrast that with defectives, and defectives data are pass-fail in nature. So the number of rejected parts in a lot is an example, and they're described by a binomial distribution because something's either defective or it isn't, right? It's pass or fail, it's go, no go, it's okay, not okay. And so at a very high level, that's the difference between defects and defectives, is the very nature of what kind of information we're expecting to get. To go into a little bit more detail, let's talk about these in a little bit more specifically, because sometimes there's just confusion in the vocabulary. And so first off, what kind of information is collected? Well, in the case of defects, the total number of nonconformances found during an inspection. Okay, so my defects are going through, I'm going to use the example of, say, doing an inspection of a water bottle, of a drinking bottle, and I'm going to go through and look for all of the things that maybe are non-ideal about that bottle, and I want to keep a running list of all of those items so I know what kinds of issues I'm facing. Contrast that with defectives, and there we're looking for the total number of non-conforming articles found during an inspection. So defective will count the number of items that aren't fit for use. And so already there's a difference here where defective is making kind of a pass-fail decision on an item, whereas defects are actually counting all of the various attributes of that item. So how do we use this information? Okay, so for defects, I'm going to say understanding and reducing the overall defect levels is an important reason to actually perform defect collection. And you'll notice I'm using the word defect to define the word defects. But I think overall defect levels are something that most customers and most folks understand. And so that's really the goal of collecting defects data, is to understand all of the things that you might be facing versus defectives, where we basically want to count the number of defective products or non-conforming products. So we're talking about scrap or rework. So defective describes the overall product, but the defect describes a specific non-conforming characteristic of that product. Okay, and then the last question I've posed here is kind of a strange one, but it's very important when it comes to the software. And so here I pose the question, what is the maximum number of counts of a defect or defective that I could find per piece inspected? Okay, and this is really important when it comes to our software. And so, for example, defects, if I pick one bottle and I go around and I count how many defects that there might be on that bottle, I can find an unlimited number of defects, right? I could pick up one bottle and find 100 things wrong with it if I like. But how many times can I count that one bottle defective? Just once. Okay, and so that's where a big distinction between setting these up in Proficient comes into play. If I tell the software I'm inspecting 10 bottles, if I choose a defects test as my setup, then my defects test will allow me to find as many defects as I want off of those 10 bottles. If I choose it as a defectives test, well, those 10 bottles, the maximum number of defectives had better be a maximum of 10, right? I can't find more than 10 defective bottles. So carrying on with this, I promised you this was coming, and here it is. Let's visually inspect a plastic bottle. Okay, so how many different defects might we find? Maybe there's a missing label, a wrong label, torn label, scratches, dents, pits, holes, etc., etc., etc. You name it. Okay, so every hour, let's say we grab 10 bottles and inspect them. Okay, so every hour we go out, we grab 10 bottles, and we start looking them over for these various defects. And again, I'll pose the question, what's the possible number of defects that we might find? We could find an unlimited number of defects. Okay, so great. We'll take a list and we'll start noting which ones had torn labels and scratches and dents and so on. But do these results mean that the bottles were scrapped? So again, comparing and contrasting defects versus defectives, defects is going to give me a running list of things, but certainly some of these defects might result in the bottle not being fit for use, right? If I find a hole, well, that's a key tenet in having a water bottle that's fit for use. But maybe I find some scratches and dents, and while I'm not happy about that, I may be able to allow it to go through and be fit for final use. So again, we need to make sure that we understand what it is that we're looking for. And so in addition to those defects, well, what if we did want a count of scrap bottles? Well, in that case, then we'd probably need to set up 2 tests. So depending on the information required, you may need either one or both of these types of tests in order to get the information that you're looking for. So it's very important going into attribute data, understanding kind of what your goals are as a takeaway. Okay, well, we've decided on defects data because, well, that's the topic of today's webinar. So what kind of charts can we use with defects data? Okay, in general, we can use control charts, which basically, like all other control charts, kind of give me an expected amount, right, my expected average and variation. So here I get the expected number of defects per collection. And we've got several charting options, and we'll talk about those more in the coming slides, and we'll see them in the software. We basically have, for defects data, C charts, U charts, DPMO, DPTO, which stands for defects per million opportunities, or defects per thousand opportunities. And you can see we've got reasons for using each of these. C charts are when I've got a constant subgroup size. A U chart is if I've got a variable subgroup size, so maybe I'm not always collecting the same number of bottles every time when I'm doing my inspection. And my defects per million or thousand opportunities are used so I can plot products of varying complexity on the same control chart. Okay, the other big chart, and this is the one I'm a very big fan of when it comes to defects data, are Pareto charts. While control charts tell me kind of the expected number or average number of defects that I can experience, Pareto charts allow me to sum and organize these in various ways. The first two here, a value Pareto and a count Pareto, are very similar. They're basically summing counts of the defects that I've found. The difference between these two is a value Pareto allows me to assign significance. One of the examples you'll see on my product, I'm going to be looking for critical defects, major, minor, cosmetic, and maybe I can say, well, a critical defect is very, very important, and a cosmetic, while I'm not happy about it, is less significant. I can assign different values to each of those defect codes, and so my Pareto will be scaled accordingly based on those different values assigned to the defect codes. So I can either do a count of how many instances I've seen of those guys, or I can sum against the value and get kind of a, again, a scaled version of it so I can see where most of my emphasis needs to be placed. Similarly to that concept is a weighted Pareto, where I can multiply the value or the count by what we call a weighting factor. And this weighting factor is often either a cost in dollars and cents, or in time, maybe rework time or something of the like. And so I can actually then not just look at counts of things, but I can start to assign an economic value to those, which helps me understand where I should be going with my analyses later on. And then finally, parts per million or parts per thousand. If I've got products where I've got maybe different volumes or again, kind of different complexities, it allows me to help normalize and understand these values a little bit better. Okay, so we'll talk about all of these in a little bit more detail. Control charts for defects data. Okay, I had mentioned the C chart and U chart, and what's the difference between those two? Okay, in a C chart, each subgroup counts the defects found. Okay, so that's pretty easy, and that's why it's important that the subgroup size be constant, because if I find, if I take 10 bottles and inspect them and I find 3 defects, and I take 100 bottles and inspect them and also find 3 defects, well, my proportion of defects is very different on those sizes, and so just a raw plotting of the counts isn't really representative of what's happening. Okay, if that's the case, that's where I can employ a U chart, where each subgroup is a count of the defects divided by the number of items inspected. Okay, and now this allows subgroups of varying size to be plotted on the same control chart. Okay, so very, very similar charts. They both just deal in counts, and then we, in one instance, it's just the raw counts. In the other instance, it's divided by the number of items inspected. Okay, and then we get to our defects per million opportunities or defects per thousand opportunities, where each subgroup represents the count per the number of opportunities specified for that product. So for example, I can now have products of varying complexity to be plotted on the same control chart. All right, and I am not going to approve the request to annotate. I'm sorry, I'm just going to keep hopping through this, and we'll talk questions at the end. Okay, so next, let's take a look at some of these statistics that we might actually use on these charts, because if I'm dealing with attribute data, how can I have statistics based on my control charts? How can I use statistics? And well, the main statistics that I'd be concerned with for any data set really are my estimate of mean, my central tendency of my data. On average, how many defects can I expect? And then my sigma, my variance, okay, well, off of that mean, kind of plus minus how many defects can I inspect? Okay, and for C charts and U charts, I get these metrics here. Again, these came off of the SPC Pocket card, so if you've got one of those handy, you can always take a look at one of those for your reference. And you can see that these statistics are very similar in nature. My center line for both my C chart and U chart are basically the summation of the points divided by the number of subgroups on the chart. And I apologize, PowerPoint in presentation mode does not like bars above the C for some reason, so it looks like a small tick mark, but on the non-presentation slides, it's the full bar, so there is a full bar here. And then similarly, my estimate of sigma is the square root of that average variation. So that's where I determine my control limits on my control chart. Of course, with the exception being as I approach 0, obviously I can't have negative defects on my control chart, and so my lower control limit effectively just goes away, and I just have an upper control limit. Okay, so now we go to the defects per million and defects per thousand opportunities, and I use the example, what if we wanted to count the number of errors made on a form? Okay, so I fill out taxes or a job application, or I'm a big radio-controlled airplane enthusiast, so I've got various forums and such that I visit, and I have to fill out forms. And let's say that we make forms, and we want to understand the kinds of mistakes that folks make on the forms that we make. Well, certainly forms of different complexity have different opportunities for errors. So here, I've got a very simple form. Okay, I've got a simple form. It's a guest list. I put my date, the date that I was there, my name, my address, and some sort of comment. I only have 4 opportunities of making a mistake. Contrast that with my friendly 1040 form that I fill out every year, and kind of depending on how you count, I got about 87 opportunities for making a mistake on this form. Okay, so again, we have different complexities, and we need to talk about if I make one mistake on the first form and one mistake on the second form, it means different things in terms of proportion to the number of mistakes I could have made, right? And so if we take these two guys and actually wanted to plot them on the same control chart, basically I'd plot the number of defects divided by the opportunities, and so now I kind of normalize out that complexity, and I can display that information a little bit more meaningfully on a single control chart. Okay, and Proficient offers plotting defects per million opportunities, defects per thousand opportunities, known as DPMO and DPTO, respectively, and they're really the same statistics. They're just off by 3 orders of magnitude. Okay, so I mentioned I'm a big fan of Pareto charts, so a very reasonable question might be, well, what's so great about these Pareto charts that makes them so interesting to you, Eric? And even though you're all muted, I'm glad that you collectively asked that question. And so the biggest thing that I really like about Pareto charts is the ability to total my defect counts based on the criteria that I'm interested in: parts, processes, tests, shift, lot, employee, etc. Right? A control chart, it shows how many defects to expect on average, but often we're interested in these total counts, right? How many defects have we had on this part in the last week, or which line is giving me more defects? Things like that, which takes me to my next bullet. My Pareto chart allows me to very quickly change the criteria order by which my data is sorted to answer these very questions, right? Which line is producing the most defects? Which product has the most defects? Did a specific lot have more defects than others, right? Maybe I need to partition that lot off and make sure that I don't send it out before I have a further look at things. Okay, or what are our monthly defect totals for the past 6 months? All of these things are easily accessible through a Pareto chart. Okay, and then I can also very easily switch between defect counts and weighted counts, where I was talking about weighting my values by cost or by time. I can do that with a single click in a Pareto chart, which again is very powerful. And as we go through our demonstration, we're going to show where that can have a significant effect on kind of the results that I'm looking at. Okay, so for those of you who are avid Proficient users, you know there are lots of options in the software, and some of those are specifically geared towards attribute data collection. So, what are some of the specific options that I should be using in Proficient when I'm collecting defects data? Okay, the first one is actually more of a conceptual thing to consider, but using the inherent built-in defect code functionality that we have in the software, which allows the user to assign a value and then determine how many of those defect codes were selected just from a pick list. Or I can actually create individual tests for each defect, which is a lesser used way. But these methods offer options of really ease of entry, and it does change a little bit your options for data analysis, but ease of entry can be very interesting when we create individual tests for each defect. So I'm going to show an example of that, because depending on how you're planning to use the data, you may want to choose one method over the other. Okay, there's a very specific option in the data entry configuration called auto increment defect code count. And I have many customers say, what in the world does that mean? And basically what that means is, as the operator goes through, they can just choose a defect code, and the data entry window automatically knows which value should be associated with it. There's a field I can populate in the database that is associated with the defect code, and when I turn this option on in my data entry configuration, the user no longer needs to type the value. All they do is select the code, and the software just chooses the appropriate value. Okay, there's another option called default attribute test to 0. And this is a pretty cool one. It allows the user to save a subgroup without actually selecting a defect code. So you might say, well, that's kind of strange. Why would I want to do that? Well, let's go back to our water bottle example, and I grabbed 10 water bottles. I certainly hope that sometimes I'm able to actually get my whole collection of water bottles and find not a single defect. Well, then how do I tell the software that I've actually performed my collection, that's where this option comes into play. There's an option to automatically open the code list. That just opens the list of defect codes for the users. Pretty self-explanatory. There's an option to combine multiple code lists. So if I have multiple things that I'm looking for, I can allow the user to just have one long pick list. And I'll show that in our demonstration. Makes things a lot easier for the user. And then there's an option for force each row to count as an item, which helps ensure traceability of piece data because you kind of know what went with what. This is huge when we're using defectives data, so I'm going to use this as a teaser to say, hey, tune into the defectives webinar, and you'll see this one in action. Okay, last slide before we go to the software. Spec limits for defects data. How do we use spec limits when collecting defects data? Okay, and first off, it brings up a topic that not everyone's familiar with these. Everyone's that's using spec limits in our software, I think, is familiar with piece limits. I can come in and say, I expect, or I don't want any more than, say, 3 defects per part that I inspect, right? Or maybe, yeah, I don't want more than 3 defects per part, but really give me an alarm when I get more than 3 defects per part. But I also have the option for subgroup limits, which allows me to look at the entire subgroup because I might violate on a single piece, or maybe I have low defect counts on each piece, but many pieces have defects. Okay, so piece limits alarm on the number of defects on each piece, whereas subgroup limits are based on the entire subgroup, and it's specified then as a proportion of the subgroup. Okay, so when appropriately set up, you can trigger alarms based on individual pieces and or the entire subgroup, which is a pretty neat way of being able to function. Okay, and then the other piece that you have to understand when setting up the spec limits are, as I mentioned on the previous slide, I can assign values to each defect code. Okay, so I can have a list of defect codes, each with their own assigned value, but the specs are set against the individual test. And where this can be useful is it allows then each defect to count independently against the test. So I can actually have a big long list of defect codes and say, you know what, this defect code is more important than this other one here, so I'm going to give it a higher value, and I can actually do some summing of those defect codes, and I can then violate based on that summation. All right, so we're going to leave the wonderful world of PowerPoint, and we're going to head to the software. And as I sign in, and I was trying to think of what my background would be for the project, I thought, what more appropriate searching for defects than a Where's Waldo image? And now, so I don't lose everyone's attention, here's Waldo. He's right here. Okay, so you don't have to sit there and stare at the screen and say, geez, I wonder where Waldo's at. That's him. Okay, so let's take a look at some of these scenarios that we actually use. This first one is making injection pens for a medical company. Think of something like an EpiPen. Okay, so it's a pen that's got a needle in it that I use to distribute medication. Okay, and I've got several scenarios for things that we talked about to kind of show defect data entry in action. So I've got all of my usual things, and for today I'm going to be Jeff. Okay, and we can see first off, I've got 4 individual tests. I've got cosmetic, critical, major, minor. And each of these tests is set up with its own defects list. And so for me to make an entry here, I can say, oh, I found 2 instances of burn marks in area B. Okay, and you'll notice for cosmetic tests, I actually have a spec limit set up that I can have no more than 4 cosmetic defects on any one piece. And so I can come through here and say, oh, and I found one of these, and I found one of these. Okay, and then I hop over to critical and say, nope, I don't find any critical violations. Right, here's my list of violations, but I don't have any. And I can come here and say, oh, I found 1 instance of the company name missing and an instance of missing the product name. Okay, and I can come over to my minor defects and say I found 2 instances of a letter missing from the product and 1 instance of an incorrect glue joint. And when I click Save, we can see that all of my control charts have updated with the appropriate information. I'm happening to use a subgroup size of 100, so it's a fixed subgroup. And so I'm using C charts to just show the raw counts. So we can see cosmetics, on average, I'm getting about 2.5 defects per piece that I inspect. Critical, I'm getting 0.06. Major, I'm getting a little over 1. And minor, I'm getting about 1.3. So that's what my control chart's telling me. Let's go take a look at that data entry configuration and see how I've got things set up. My data entry configuration has the 4 independent tests. And if I go look, the test is set up as type defects. And that's where we were talking before about defects versus defectives. It allows me to know what kind of counting to expect. And then down here I've got a list, and I say, okay, for the cosmetic test, this is the associated defect group. And that's what populates the list with those values. I really don't have many options turned on other than the default attribute test to 0, which effectively allows me to save a blank subgroup. So I'll cancel this data entry configuration, and we're going to go to something that I think is a little bit more user-friendly. Okay, it's the same part process test. I'm still going to be Jeff. We're still looking at the 100 pieces in our subgroup, but notice here, I just have one long defect list. Okay, so what I did is I turned on the option to combine the multiple defect lists into just one list. So now I can say, fine, I found one instance of this, and I found an instance of this guy, and an instance of that. Okay, and so my operator can just scroll through one list. They don't have to know which defect codes live in which list or which test they're associated with or anything like that, which I think is pretty neat. Okay, we still have the requirement of needing to type in the value. So I say I found 2 instances of, let's go down to something here. Okay, we'll do a string. Okay, and we save that. Okay, and my charts populate. Well, and actually before we go one further, let's take a look at my data entry configuration. It looks exactly the same, and it really is almost exactly the same except for just this one option. Under attribute coding on advanced options, I said let's combine the multiple lists into one. Okay, so I just turned that guy on, and that's what gave me then the one long list. The next instance that I just wanted to show, following along with this exact same example, I'm still all of these same things. You'll notice that I turned on the option for the code list to automatically open. So I just always have it open, and I can come through and say, oh, I found a minor. And you'll notice I didn't have to specify a value, and my code list actually closed. My code list just reopened, and now I've closed it so I can see in the background when I chose this glue joint incorrect, you can see the number 1 here. This value was automatically assigned based on my selection. And so you can see through as I go through here and I make my selections, my background just keeps filling up with 1, 1, 1, 1, 1 because those are the values that I've associated with those. So I think this is a very convenient way for an operator to not even have to type the values, right? They can just, as I've got the bottle in front of me and I go to the next one, I'm now just using the arrow keys, and I can go down the list and say, yep, I found embedded debris, company name is missing, biocontaminants, et cetera, and I can very quickly go through those items. Okay. So what do we do to make that happen? Again, I'm going to go take a look, and it's very similar. It's the same tests here. It's the same combining the multiple code lists, and the only things I've really turned on are the auto increment defect code count. So this is what automatically gave it the 1 every single time. And I turned on the option to automatically open the code list. This is a very polarizing option. Some people look at this and say, of course, this is what I want. And other people look at it and say, that's a horrible idea. Why would anyone want that? And so it's always funny for me to see when I go to a customer site that, whichever way I recommend, I think is always backwards. So those are the options that I turned on for that example. And everything that we've seen so far has been into our C charts. And just so I can actually show results in a U chart, I took the same data entry, but this time I made the subgroup size variable. Okay, and so I'm going to say this time I'm going to only inspect 10 products, and I'm back to my other method of doing this, and maybe I'll say, oh, there's one instance of the company name missing, and there's an instance of a cracked or broken component, and 2 instances, let's make it 3. 3 instances of some burn marks in area A. Okay, so once I've got all of those in and I click save, wow, I start to get some alarms. And you'll notice that it says, okay, my major violated my upper subgroup limit, and my cosmetic violated my upper subgroup limit. So that's interesting. Let's go take a quick look at my spec limits. So here I am on cosmetic. We can see that I specified a maximum number of 4, but my most recent entry only had 3 values in it. Well, I didn't violate my piece limit, right? I didn't have a single piece that had 4 values in it, but my subgroup, if we see this, I said if my subgroup has, 25% of the sample size or more in defects, I want an alarm, and that's what I violated. My 3 defects were 30% of my subgroup of 10, which violated this limit. Okay, so it's just a neat way of being able to see some of that functionality. So we can see my U charts, they're almost the same as my C charts, though the numbers are based in proportion to the subgroups. So we're looking at 5% instead of, say, raw counts. Okay, so we've spent all this time seeing these control charts. One of the things, though, that I wanted to talk about next are all the Paretos I've got down here. Control charts are fantastic for telling me, here looking at cosmetic, I can see on average I get about 2.4 defects per piece. But this doesn't do a very good job of telling me which defects I have. Right? I had 3 points in a row here that each had 4 values in them, 4 defects, but were they the same 4 defects? Was it one defect reported 4 times? How can I get to that information? Well, that can be a little bit challenging from a control chart. I can do it, and I even have options to go in and say, you know what, I only want to see, give me a control chart for burn marks from area A. Oh, okay, that's interesting. Right? Or I can go in and I can say, I want to see, all of my burn mark defects. Okay, it starts to sum them that way. So I get some very interesting results, and I can do some very specific things with these control charts. But oftentimes, if I'm not doing troubleshooting or specific process improvement, the best place for me to look at this information is on my Pareto chart. And so let's just spend a moment going through these Pareto charts. Here I can see all of the defects that I found based on the category, and then I've even summed them up a 3rd level, which is something new in Proficient 4.4, that I can go beyond my 2 levels of filtering. And so I can see I found a total of 201 defects. 92 of those were cosmetic, 50 of those were minor, 48 were major, and way down here, 11 of them were critical. Okay, and then all of the associated defect codes with those guys. So that's very interesting information for me to be able to get in a very quick manner. And then further to the left, I start to get some of the percentages and things that make this up. I had a total of 201 pieces or defects found. 92 of those were for cosmetic reasons, which is about 46% of the total. And then I can go in and say that's, for embedded debris, that's about 16% of the total. So I can start to get, visibility to all of these levels of things. Or if I want it normalized to number of pieces inspected, I've got this column here telling me that I've inspected 2,690 pieces. And now I can see the associated percentages for those guys, as well as PPK and sigma level values that are calculated based on fallout rates in the ppm fallout rates for distribution. So I get all of this information on a Pareto chart, which is really cool. And then the fact that I can go through and I've got some pre-configured already just to make my life a little easier, I can have them filtered maybe by lot, so I can see which lot gave me the most issues. Or I can go by line. Here I've got line 1 has got more than line 2, but if I say, boy, I'd really like to understand, maybe not down to the specific defect code, but just to what kind of violations I found. Okay, I can just go to the test, and now I see of the 201, 92 were cosmetic, 50 were minor, 48 major, 11 critical, and so forth. Okay, this is just great information for me to be able to filter through very conveniently. Or by inspector. Okay, who's the individual who found those? All right, Jeff is the one that's found most of them. Maybe he's got a better eye than other folks. Maybe he should be training other folks. Maybe he's too critical, right? All of these things might help us better understand our defects, because defects, just by their very nature, that attribute data can sometimes be difficult to wrap your mind around versus variable data. Okay. The next Pareto I want to show you, I want to revisit this guy where we looked at our total counts by category, and we can see of the 201 that we found, 92 were for cosmetic reasons. And so if I were looking at this Pareto, I might say we really need to tighten down our cosmetic defects. Okay, so we say, yep, that's what we're going to do. But notice this, I'm going to go to the same control chart, but this one is weighted based on cost. And something I set up in the database, and I'll just show you very quickly. These are all my minor defects, just as an example. You can see I've got this column here for factor. I assigned a different factor to each one of those defect codes. Some of those are zero cost factors. Some of these I said here, if there's an incorrect glue joint, it costs me $0.25 to have that fixed. If there's a missing billet, it costs me $1. If it's a short shot or missing plastic, I might have to scrap the whole part, and that's $2.50. So I've assigned these numerical values here, and that allows my Pareto then to be weighted by those values. And now I can see that I've had almost $117 worth of defects, and $54 of that was because of major defects. Minor defects were $33.75, critical were $27.50, and look at my cosmetics. Even though I had so many of them, their cost was so low that it was only $1.47. So this may help me redirect where I should be, putting forth my efforts. Okay, so this project, I know I've gone through a ton of stuff in here, and today's talk isn't going to be comprehensive. It's probably not going to give you, every answer that you're looking for. But what we're trying to do is show you some of the options that are in the software and things that you can take advantage of for your use. So this is very typical of defects data entry. I did want to just show an example of my my defect opportunities. So I talked about defects per million and defects per 1,000 opportunities. So here I'm soldering circuit boards. Certainly not all circuit boards are of the same complexity. And so I can look at my solder defects, just as straight counts, but how do I start to compare soldering boards that have different numbers of opportunities associated with them? That's where my DPMO chart comes in. So now I'm looking at the defects per million opportunities, and well, how are those opportunities assigned? Those opportunities are assigned right here in the defect opportunities table, where I say for this part, okay, solder defects, there are 100. But for this part, there are 200. For this part, there are 150. And for this part, there are 400. So you can see I've got it hard-coded into the system which parts have the most opportunities. So when I perform my data collection, I'm able to just do my normal counts like I would and let the software just in the background generate these defects per million opportunities. And then I've just got two other instances of what I think are very clever data entry options. And I wish I could claim credit for these, but credit goes to our intrepid Steve Wise, one of our industrial statisticians. And he's got two scenarios here that I thought were very interesting. Here I'm looking for defects in various zones. And so what we didn't want was the operator to have to make all kinds of selections for things. It just says, I really want something simple that my operator can just choose. So I can see the number of defects in my Pareto here, and I can come through and say, oh, I found a defect in zone 6. And I click on the button, and you see, boom, my zone 6 defect count just went up 1. I click it again, it goes up another 1. Oh, I found one in zone 3. Oh, there's one in zone 2. Oh, another one in zone 3. Where you can very easily perform this data entry. Okay, and so how are these types of entries performed? It's quite clever. Each one is its own data entry configuration, and each one has only one test. And you'll notice my test is named Zone 1 defect, and I have another test for Zone 2 defect, Zone 3, etc., etc. And each one of these is set up as a calculation, and it's about the simplest calculation you'll ever do. Just enter the number 1, which means it's going to return the number 1, and it's going to allow my Paretos to tally. Okay, so I thought, boy, that's a really cool way of being able to get my data entry to occur. And then, of course, there are the options I need to turn on to automatically save a completed subgroup and automatically close subgroup on save. So everything's invisible to my operator, and it's just kind of one-click shopping for my defects. You know, there's zone 10 had a defect. You know, just, wow, it just updates immediately. How cool is that for your operators to be able to just walk up to a screen, if this were a touch screen or something of the like, very easily be able to make those selections. And I will not save the changes to the project. And then finally, this is a very, very similar option, but instead of different zones, it's just different tests. So looking for defects in air sac bruises, cadaver contamination, et cetera, et cetera. And again, I'm able to just make those selections and watch my Paretos grow and really show me at a glance what kind of defects that I've been encountering on my production line. Okay, so nothing really big here in terms of the actual setup of an analysis. I'm not using the control charts here. I'm just using the Paretos because, again, it's a very effective way for me to get kind of this overview and review information. But I think it's a very effective way of allowing data entry to be more straightforward for the operator. But of course, I don't have those defect codes assigned with the tests. It's just the test name itself that's actually my filtering level. Okay, so that's what I had prepared for the demonstration. I'm sure after the PowerPoint talk and seeing this information, I'm sure there are plenty of questions. So I want to thank everyone for their attention, for attending today. Please return in 2 weeks for our defectives talk. And Ed, I'm ready to open the floor for questions.
Okay, good deal. It's pretty informative stuff, Eric. Thank you a lot. A couple of questions are starting to trickle in. Before we get started on that, I just want to give another reminder. The follow-up session for this on defectives will take place 2 weeks from today. The good Mr. Weisbrod here will also deliver part 2, getting the most out of defectives data entry and analysis. You can register at infinityqs.com. There's a little button, a little ad in the lower left. You can hit that, and it'll take you to the registration area. So getting started on a couple of questions here for Eric. First is, are there any options that you showed today that are only available in the newest version of Proficient? Can you speak to that, Eric?
Sure, that's a good question. Most of the things that I've shown have been available in the software for a long time. The main things the only thing that's specific to 4.4 is my ability to generate a Pareto chart going to multiple levels, or beyond 2 levels. Sorry, we've always had 2, but going beyond that, that's a 4.4 thing. And somewhere around the early Proficients is when we started allowing the auto increment defect code count option, and and the value. And I don't know offhand which version of the software that came into play, but if you're running 2004, it most certainly wasn't available in 2004, and I want to say maybe somewhere around Proficient 2.
I see. And just a reminder, you can go ahead and add questions. We're monitoring both the Q&A and the chat, so you can send them in either way. Can users enter their own defect codes?
They can. It's an option in the data entry configuration. It's something I would strongly, here we go, allow new codes to be created. It's something I would strongly caution you about, using, just because I've seen defect code lists that get very polluted with things that aren't defect codes. Someone accidentally puts their password or their username, or they type their weight in, or what have you. They aren't paying attention to what it is that they've got up. So it's something to be careful with.
Okay, I see. This one's coming from Julio, and he's wondering, can I get some insight into the use of defect control versus lot acceptance?
So our acceptance sampling. That's a great topic, and that's a that's a large topic as well. Um, Basically, what we've got set up in Proficient, and this is probably a good offline conversation. You know, Julio, if you want to call and talk with one of us specifically one-on-one, you know, that's very possible. But in general, what we've got in the software is the ability to create acceptance sampling plans, where I can specify things like the AQL level I'm expecting, my alpha and beta risk, my lot tolerance percent defective that I'm expecting, and as you can see, I'm trying to navigate and talk, and so you know, here's an example of an acceptance sampling plan. My AQL level, what I might expect for a specific lot, my alpha and beta risks, and then I generate a test plan of when to accept or reject those guys. And so we've got data entry configurations that you can create that are specific for AQL type testing. So we can go into more detail on that probably offline, but that's just a quick overview of what's available in the software.
Okay, very good. This is from Miguel, and you'll have to help me out on this, Eric. Is it possible the first example, is that just a demo project that's available to everyone?
The very first in the first demo project that I've got up, I've modified one of our standard demo projects from our SPC examples. So it is available in the examples database. And sorry, I'll just drive there real quick. If you've got our examples database, you can go to the industry examples, and then it's in medical because we're making those injection pens, and it's injection pen inspection, and you'll see here all of the same. Of course, mine is messed up with the data that I've just put in, but it's got all of those options set up there. But I did add a few things myself, and potentially we could maybe make that available, but I don't have something that I can zip up and send out right now.
All right, that's fine, and Miguel, we'll get back to you on that. We got your information. Next question coming from Ricky. Ricky is wondering, and this goes back to the windshield example towards the end there. Is there a way to enter a part that passes using the defects button? You know, showing how you had it in the zones like that.
To enter something that passed?
Yeah,
you certainly can. You certainly can. Typically, what we do is we assign a pass a value of 0 and a fail, you know, a value of 1. I guess we'd have to have maybe a little bit more of a conversation as to exactly how you want to accomplish it. You know, what's your result that you're looking for? But it certainly is possible in that example. But typically, if I'm doing more than one code, I like having the defect codes themselves. But yes, you could absolutely create a test called, you know, Zone 1 pass and have that enter as well.
Okay, very good. Coming from Stephen, is there a way to make the percent total show 100% per part instead of the percent total per all data entered? You got that?
Percent total per part versus, yep.
Okay.
And so we want the percent total, and actually that's by category. The short answer is yes. The long answer is I'm going to have to jump through a few hoops to make sure that I get things correctly. But as we can see here, this is summed up based on it's based on the test group. And if I come up to the part, I can see now that 100% of these are for my blue pen. So if I'd had multiple products, you know, inspected here, I can see that by those guys. So I need to change a few other things with the chart to get multiple parts in here and such, but in general, yes, that's possible.
Okay, very good. And that screenshot of the windshield, is that available? Is that available in the project as well?
That is not. That is something that Steve Wise came up with, but again, I think that would be something we could potentially release, but it's not something that's currently in the projects.
Erica, I'll send you an email with that screenshot, so look for that. This is coming from Alpesh. How to set up a Pareto shot which you have just shown. How do you set that up, that Pareto that you just showed toward the end?
So basically, I can say I'm going to make a new chart. If I want it linked to a data entry configuration, it's a Pareto chart. It's going to be based on sampled data. Okay, I choose my data selection just like I would from any chart. And then the most important part when it comes to Pareto charts, and box and whiskers for that matter, are choosing the categorization. So here it's categorized by, and so we'll say let's make it first by test, and then by defect code, and I have some, cosmetics that I might want to add to it to make it so I can see more data on one screen. But it's pretty straightforward in terms of just doing your data selection, and then always remember on your Pareto, right-click and go to processing, and processing is your friend to get things ordered differently.
Okay. Okay, very good. And Eric, this is coming from Miguel again. Could a downtime analysis system be created using the time of stop as a defect? Have you ever seen that done?
Yes, and there are a couple of ways you can do that. You can, we've got some folks, and this is actually, it's in our demonstration projects where you can enter the number of downtime minutes, for example. So you could enter that I had 7 minutes of unscheduled downtime and 5 minutes of scheduled downtime, so I'm manually doing that. Or we do have, in the toolbar button, we do have the downtime command, which creates a downtime event that basically puts the line in downtime, and then I've got the ability to look at that in an event Pareto, but based on time, and then you can get total minutes of downtime or time between assignable cause, corrective action, etc. So there are a couple ways that you can do that. Okay,
very good. Jonathan here liked the example of the one-click data entry.ipj file. Do you have an example similar that you can use as a model? Is that available?
Again, I think that's something, yes, I think that's something we can send out. I believe Steve Wise did that at the last Infusion as one of the training class sessions, I think. So I think we've got something that we could send out.
Perfect. Hey, you mentioned Infusion, Eric. Did you know that Infusion this year is going to take place in Denver from September 23rd to 26th?
I did not know that. Is there more information you would like to tell me?
Well, the conference is attended by the best of the best in manufacturing quality control, and it's a great opportunity for users to grow their skills and their professional network.
Fantastic. But all joking aside, on my end, it is a great venue, and if you want a chance to see some of these things hands-on, or again, do some of these things as part of a training class, it is some great availability.
Sure. I think we've got a few more here coming from Michael. Will the size of the Pareto charts ever be dynamic so it expands and contracts based on the amount of data?
That is an excellent question. I don't have an answer for that, but that's a great recommendation for if you want to submit a change request through our technical support group. That would be, I think that's a fantastic idea. So.
I appreciate that, Michael. And I'm trying to scroll through. Any last questions? Please send them into the chat. Go ahead,
and I'm looking in the Q. I'm looking in the Q&A. Sorry, and there are so things all over. Let's see.
Sure.
One said for the C chart, the sample should always be the same size. Yes, that was from Eduardo. Another question from Eduardo said, does the factor work for all versions? The factor should be there in 2004 3.3. Yes, that should be there back through for the factoring, but not the value. Request for a demo project. Will the webinar be available on video? Correct, Ed, right? We post we post these webinars?
Yeah, that's right. We'll send them out by tomorrow in an email to everybody that registered. We've also got them on the website, and you can go back and look at the ones we've done in the past. I do have a long website name. I'll read it as quickly as I can. infinityqs.com/resources/demos-presentations/archived-webinars. So yeah, all of our old archived versions on there. Great educational content for anybody who's coming in or anybody who needs a refresher. It's good for that as well.
And I've got just a couple more here then. I have a question here from Matthew, saying everything I've seen so far is geared toward real-time data entry. All of our defect data entry is performed via Oracle forms, and analysis is done after the fact by selecting a part and parading out the defects in a given time period. Absolutely, we've got tools like our DMS and DCS that can, bring in subgroup data. It can bring in defects data as well as variable data. So yeah, that's awesome. If you've got another way of getting it in, that's fine. So
that's good. I've got one more from Kent. You see that?
Okay.
Or I'll just
yes.
read it.
Can you tie any of this data into yield calculations?
There we go.
Is that what you're?
That's the one.
Is it a different? Okay. So to answer that, you can certainly perform some yield calculations as part of the data entry config. When we start to talk about things like yield, that will also be part of our our defectives talk. It's still going to be in Pareto's where I can see percentages here, but when I start talking about defectives, I'm then talking about scrap or non-conforming parts, and that's where I can get the yield information from. So we don't have specific things that are this is specifically for yield, but we do have some ways of getting that information. Another question: are you going to send info of this presentation by PowerPoint? Yes, we'll make a PDF of it, and I think that'll be available. Is that correct, Ed?
Yeah. I'm gonna put that in the email that we send out tomorrow. So the archive and the PDF will all be in the email, and everybody will get that. Infinity QS will be the sender.
Okay, and then the last one that I have here is: can the Pareto be rotated 90 degrees counterclockwise? Nope. In terms of this is the default view that we've got, and we don't have an option to rotate the chart. So if I'm being a smart aleck, you could take your laptop and hold it sideways, or all joking aside, if you did want it to present differently for a document or something, certainly we have ways of getting the graphics out where you could rotate it there. But sorry, I don't have an option to have it rotated.
Well, fantastic, sir. I'm not seeing too much more here.
Normal spec graphs. I'm not sure. Gustavo had just asked a question. Can we normal spec graphs with this kind of graphs? I'm not sure what that one is specifically asking. So this kind of graphs, can we mix them? I'm sorry, Gustavo. I'm still not with you, but I know we're running out of time. Maybe if you want to call in with tech support and say, hey, I want to talk to someone a bit more about these graphs. We can definitely give you a hand there as well.
And just as a general, for everybody who doesn't know, our tech support is the best in the business. Those guys are fantastic. I hear them every day. They are committed to solving people's problems. So really, anytime you have anything, you run into any little bump, go ahead and call our tech support, 1-877, what is the number here?
772-7978?
That's the one. So they really are first class, so I know everybody's had a good experience with them. So anyways, I'd like to thank you, Eric, for your expertise and time today. Thank you for all the attendees. I thought it was a really informative session. Again, we'll look forward in 2 weeks. You'll have bigger and better things, I'm sure. I'm looking forward to the